Problem solving. Intermediate. The following problem is not hard, but many find it confusing at first. Well, without further ado, let me formulate the problem. It is a fun problem. Problem. Cards are drawn from a deck of cards without replacement until the ace of hearts appears. What is the expected number of drawn cards? Okay, so we have a deck of cards and we draw cards one at a time until the ace of hearts appears. And then the question is, okay, so here I have ace of cards, and then the question is, how many cards have I drawn? So here I've drawn 5 cards. But what is the expected number of drawn cards? A reasonable random variable x here would be the random variable that counts the cards until the ace of hearts appears. Of course, you may study the experiments step by step. The first card is an ace of hearts with probability 1 over 52, and with probability 51 over 52, it is not ace of hearts. Then, if it's not ace of hearts on the first step, then with probability 1 over 51, it is an ace of hearts on the second step. And it is not an ace of hearts on the second step with probability 50 over 51. You can continue this argument, but you see, such an argument leads to an expression that is not easy to compute. Because of that, I will consider a slightly different setting. Solution. Before we start pulling the cards out of the deck, let's introduce the random variable y that tells us the numeric position of the ace of hearts in the deck. Say, if the ace of hearts is the first card, then y is 1. If the ace of hearts is the second card, then y is 2. And if the ace of hearts is, say, the fifth card, then y is 5. Of course, all possible positions are equiprobable. So, for example, the probability that y is 7 is the same as probability that y is 23, and these probabilities are always 1 over 52. On the other hand, if the card is in the case position, then it will be drawn at the case drawing. In other words, to find out the expected value of the number of drawn cards until the ace of hearts appears, we just need to calculate the expected value of y. The expected value of y is 1 times 1 over 52 plus 2 times 1 over 52, and so on. If you compute this, then you will get 53 over 2. So the expected value of y is just half of the deck. End of solution.